All right, ratio tables and proportions. So let's take a look at the ratio of white to black squares. So we're going to count the number of white. So we have 6 white. And we have how many black? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 6 to 18. And we can reduce this as 1, 2, 3. So that means for every 1 white square I have 3 black. If there were 10 white, how many are black? Okay, so first of all, let's look at this table. So so far for 1 white, I have 3 black. 2 white, I have 6 black. Okay, I can continue this table, so I can say 3 white, I have how many black? Well, I'm actually, what am I multiplying? 1 times what is 3, so that's times 3. 2 times what is 6, that's times 3. So 3 times 3 is, gotta be 9. Okay? So there's 9 black if there's 3 white. Okay? I can look and figure out how many white if there are 18 black. Well, if I multiplied by 3 to get the black, then if I have black, I can always divide by 3. So 18 divided by 3 would give me 6, which was our original ratio. Okay, 6 to 18. And then, of course, because 6 times 3 is 18, we can multiply 10 times 3 is 30. Okay, so if there are 10 white, how many are black? There's 30 black. Okay. What patterns do you see in the table? Well, the pattern we see in the table is that you're multiplying by 3. You're multiplying the number of whites by 3 to get your black. There is a pattern. So to get from the white to the black, you're multiplying by 3 each time. Okay. You also can look at how do I get from, the pattern is, how do I get from 3 to 30? Well, from 3 to 30, I can multiply by 10, just as I do from 1 to 10, I'm multiplying by 10. Okay? And also I can see a pattern of how do I get from 2 to 10? I multiply by 5. How do I get from 6 to 30? I multiply by 5. Okay? How do I get to 3 to 10? How do I get from 2 to 6 right here? I'm multiplying by 3. How do I get from 6 to 18? I'm multiplying by 3. So I can actually figure out what I have white and what I have black in the table by either multiplying by 3 or dividing by 3. So if I know white, I can get black by multiplying by 3. If I know black, I can divide by 3 to get black. Okay. What is a ratio table? Well, that's what we're starting to talk about with these, what I filled in. So it's going to be a ratio table is a structured list of equivalent ratios. Equivalent means equal. Okay, that helps us understand the relationship between the ratios and the numbers. Okay, so again, up here we saw a relationship. So all I had to do is multiply by 3 to get the number of black. And there is a 1 to 3 ratio to whites and blacks. So that means for every 1 white, there's 3 black. Okay. Also, you notice that ratios can be written, don't forget that ratios can be written as fractions. So again, 6 out of 18 is the same thing as 1 out of 3. Okay. So that's a ratio table. A ratio table is a structured list of equivalent ratios that helps us understand the relationship between the ratios in the table. So if you look back at your ratio table, this is my ratio table. 1 to 3 is equivalent to 2 to 6. 2 to 6 is equivalent to 3 to 9. 6 to 18 is equivalent to 10 to 13, 10 to 30. So all these ratios are equivalent. They're equal. What is a proportion? A proportion is actually an equation stating that two ratios are equal. Okay? So a proportion, all you're really doing is saying 1 to 3 is equal to 2 to 6. These are a ratio. 1 to 3 is a ratio. 2 to 6 is a ratio. So basically it's an equation because it's an equal sign. So all you're saying is two equal ratios. That's a proportion. So 1/3 is equal to 2/6. This is a proportion. Okay? So let's take a look at some examples. A person who weighs 160 pounds on Earth will weigh 416 pounds on Jupiter. If a person weighs 120 pounds on Earth, how much will he weigh on Jupiter? Okay, so let's take a look at our ratio table. So on Earth, he's going to weigh 160. On Jupiter, he's going to weigh 416. So I need to know if a person weighs 120 pounds on Earth, how much am I going to weigh on Jupiter? So we can set this up as a ratio. First ratio is going to be, first of all, I'm comparing what he weighs on Earth. So I'm comparing what he weighs on Earth to what he weighs on Jupiter. Okay, so he weighs 160 pounds on Earth, and then for Jupiter he weighs 416 pounds. That's in our ratio table. Okay, I'm going to fill out my ratio. I'm going to fill this in. So I want to know, what is the relationship between 160 and 416? Well, I can always multiply. What times 160 is equal to 416? I want to know. So what is that relationship? So I could just say, well, 416 divided by 160, that means I'm multiplying by 2.6 to get this, okay? So if I'm multiplying times 2 6/10, so that means I can take 120 and multiply by 2 6/10. So remember that these ratios are equivalent in this table. So basically I want to know how much he weighs in Jupiter. So if I know if they weigh 120 in Earth, I want to know Jupiter. How much does he weigh in Jupiter? So remember that I'm actually setting up a proportion. And remember that a proportion is stating two equivalent ratios. This ratio is equal to this ratio, okay? So if I'm multiplying times 2.6 or 2 6/10 here, I'm going to multiply 2 6/10 here. So 120 times 2 6/10 is going to give me 312 on Jupiter. And I actually can fill in the rest of this table if I wanted to. Okay, so I can actually fill in. Okay, so this is 120, 140, 100, and let's see, 130, 140, 150. So I will say 130, 140, and 150. Okay. So what your task is to see if you can fill in the rest of this table. So if I weigh 150 on Earth, how much do I weigh in Jupiter? Well, all I have to do, since I know the relationship is multiplying by 2 6/10, all I gotta do is multiply this by 2 6/10. And I get what I weigh on Jupiter. Okay? So you go ahead and multiply each 150, 140, 130 by 2 6/10. And what do we weigh on Jupiter, okay? So let's take a look at example number 2, okay? Mr. Collins mixed red paint and blue paint in the ratio of 3 to 2 for a painting job, okay? So he said 3 red to 2 blue, okay? So that's my ratio, 3 to 2, okay? So it's also in the table, 3 to 2, right? If he used 12 liters of red paint, how many liters of blue paint did he use? So I know 12 red to how many blue, okay? So if I know that there's a 3 to 2 ratio in red to blue paint, if I have 12 red, how many blue? Again, just like the other example, I can set this up as 3 red to 2 blue, okay? Remember, that's one ratio. And then the other one is 12 red to we don't know blue, okay? So it's a matter of, how do I get from 3 to 12 here? Okay, so what is the relationship? So you notice that you think about it, this is a ratio, this is a ratio. Ratios also are fractions. So 3 to 2, what's equal to 3 to 2? Well, that's going to be 12 over what? Well, I multiplied by what? Times 4 here, so multiply by 4 here. So if I have 12 red, I'm going to have 8 blue. So I can fill that in, okay, in the table, all right? So it says if he made 10 liters of paint for the painting, okay, how many liters of red paint did he use? Okay, so for 3 red, okay, for 6, I can fill this in. So for every 3 red, I have 2 blue. So if I have 6 red, how many blue? I have 4, okay? If I have 9 red, I have how many blue? I'm going to have 6, okay? If I have 12, I have 8, okay? So I can do that. So it says, well, how many? So 12, well, 10 is going to be about right here. So all I have to do is, again, if I know that I have 3 red and 2 blue, and I know that I have made 10 liters of paint for the painting job, there's 10 total. How many liters of red did he use? Okay, so 3 red, 3 blue. So if I have 3 red, 3 blue, okay, I know that 3 red, well, how many total is that? 3 plus 2 is 5 total, right? And I know the total here, which is 10. So how do I get from 5 to 10? I'm going to multiply by 2. So how many red did he use? He used 6 red. Okay. I can also tell you that if I add 3 plus 2, right here, red and blue, I get a total of what? I get a total of 5. So this is my total. Okay. If I add 6 and 4, I get 10. If I add 9 and 6, I get 15. And if I get 12 and 8, I get 20. So the relationship here, or the pattern is that if I look at the total 10, I can tell how many red and how many blue I have. And down here, I did get 6 red. Well, how many blue is 4. So we'll add that up, so 10. So we're going to talk a little bit more about ratio tables in class and proportions. So again, ratio tables is just a way to represent equivalent ratios. And proportions is going to be an equation stating that 2 ratios are equal, okay?